All right, same deal. I will go over the question briefly first. If you need some guidance, watch this part and then pause. Otherwise, you can start on your own. So first of all, we need to find the coordinates of B. We notice that B is a point lying on the x-axis. So what do you know about one of its coordinates? And we know that A is a point lying on the y-axis. So do you know something about one of its coordinates already? And okay, let's come back here. So we know that one coordinate is 0. That means you only have one unknown. How can you find the other unknown? Notice that these points, they lie on the same line. So what clue do you have? What ways do you have to solve for that unknown? And then moving into part B, suppose that AC is perpendicular to DE. Perpendicular. What did you learn in chapter 11 is about perpendicular. That would allow you to find the coordinates of A. Again, for A, one of these two coordinates is 0. That means you only have one unknown to solve. So you will you have known by this time you should know the coordinates of B already. Then you can, again, these 3 points lie on the same line. What ways can you use to solve for the coordinates of A? All right, after you found the coordinates of A, coordinates of B, and now you know that the coordinates of C is this. So in the previous examples, you should have learned that, okay, one way to do it is to let the ratio required be 1 to R, and you will be solving for R. Another way to do it is, because basically we're talking about the lengths, right? What is the length ratio from AB to BC, of the AB to BC? So a very intuitive way to do it is, how long is AB? And how long is BC? But you can do it that way. And what way can you, how do you find the length of a line segment? You have learned it in this chapter as well. Now you can pause the video and try it on your own. And play the video again when you have finished. All right, so here's how I did the questions. So as I said that EBD are collinear. Collinear means that they will have the same slope, okay? So all the points on this line have the same slope. So I picked BD. The slope of BD is equal to the slope of ED. But you can also do like slope of EB equals slope of BD. So I have one unknown B that I have to solve, and it turns out to be 9. So the coordinates of B is 9, 0. So I know this point B is 9, 0. Then next, we know that AC is perpendicular to DE, perpendicular slope. So you should know this from a previous section in this chapter. So I know that the slope of AC is negative 2, 3, and that would help me to solve for this unknown A, because we don't know the y coordinate of A, and I let A to be 0, small letter A. Okay, and solving this, you should have 0, 6. Okay, so that's the coordinates of A. So coming to B2, there are 2 ways to find the coordinates of C. Okay, I would say in terms of working, it's pretty much the same amount. So let's say we're directly finding this ratio R, 1 to R. Okay, and I will apply the section formula. Okay, and I know that I can set it use the x coordinates, okay, and set the equation that's equal to 9, or you can set an equation using the section formula and y coordinates, okay. So here I used x, and it turns out that, okay, no matter which coordinate you use, you should get R to be 1 over 3, but don't stop here, because our final answer, the ratio should be presented in integer to an integer form, okay, so it's 3 to 1. All right, another way that I've mentioned earlier is that you can use the distance, okay? You can calculate the distance. It turns out to be absurd that you might not be very comfortable with, but in this case, just leave it there, okay? Because you can still use your calculator to help you later on. And it turns out that this is square root 117, and this is square root 13. If you don't know how to simplify, just throw them into the calculator, and it should, by dividing, it should return you 3. So it's 3 to 1 as well. Okay, for this question, you will do part A1 and A2 on your own. It's pretty much the same as the previous questions. B is a point that cuts the x-axis, so you should know something about one of its coordinates. And then you will find the ratio okay, and find the coordinates of B. If you are not sure, you can go back to previous videos and see what is the connection there. And when you have finished part A, you can continue to play the video. All right, so let's continue. So what I did here was I let this be 1 to R. So the ratio of AB to BC is actually R to 1. After we solve it, we still need to find out what is the integer to integer ratio. Okay, so same thing. Applied the formula. 1 times, sorry, I used the y coordinates because y coordinate is known. We know that it's something equals to 0. So it's 1 times 1 minus 3 times r. We added them together to solve and find r to be 1 over 3. So we know that the ratio AB to BC is r to 1. So it's 1 over 3 to 1, which is 1 to 3. So AB to BC is 1 to 3. So please read the question carefully to see where the ratio, like which part first. All right, and then part B, same thing. I'm just dragging these numbers down. We know it's like a 3 to 1 from CB to BA, and then you are just solving for this unknown here. So very standard, going to repeat. All right, now let's look at part B. Now this structure is a little bit strange to us, right? You probably don't really know, oh, what does that mean? Why are we multiplying lengths together? So whenever you see this kind of structure, in fact, you need to think, what have you found previously? Okay, so how is this related to AB to BC? So let's take a look. In this expression, we see AB and AC, but not really AB and BC, okay, as compared to what you found in part A. But let's see what we can do. Ratio is actually fraction. Ratio is actually fraction. So what I'm going to do is to rearrange this multiplication into two equal fractions. This should make sense to you, right? Okay, because we know what AB to BC is. Do we know what AB to AC is? It's 1 to 3, so this ratio should be 1 to 4. That tells us that AE to ED is 1 to 4. Okay, so let's go to the diagram. AE to AD is 1 to 4. AE to AD is 1 to 4, which means that AE to ED is 1 to 3, right? And that would allow us to find the coordinates of E. Okay, so here, this is a highlight. I'm introducing, in this question, I'm introducing to you how do we understand and make sense of this structure. So you can pause and find E and come back and check your answer. All right, here you go. So I'm just using this 3 to 1 from the left to right, and applying the section formula, I'll be able to find both coordinates of E, and these are the coordinates of E. That's it.